Okay, so this question is about a kite and the diagonals of a kite. So before we start, let's remember about the diagonals of a kite. So we'll just draw a little kite here. Now, a kite, the diagonals intersect 90 degrees. So the diagonals are perpendicular. Now, we have one of the diagonals drawn here on the graph, and we can see that this diagonal has a negative gradient of -2. For every one we go across, we go 2 down, so its gradient is -2. So the perpendicular line is going to have the gradient of a half. So for every 2 we go across, we're going to go 1 up. So if I can draw this on here, 2 across, 1 up. So the diagonal, other diagonal is going to look something like that. So if we look a bit more, we are told that the diagonals of the kite intersect at M, which is the midpoint. So here is M, and that's where the diagonals are crossing each other. We're told that AM is equal to BM. So I think I've drawn B on here already. So here is where B is. It could be here, because I can see that AM would then equal BM. They're equal in length, so that's super. And the next part, we're given that BM to MD is 1 to 2. So D has got to be twice the distance from M compared to B. So at the moment, I can see at the end of this line here, that is the same distance as that. So D is going to be further up here, so it's twice the distance away. So if I draw D up here, there we go. So drawing it up, this is what the kite would look like. And the question is, what are the coordinates of B and D? And it says possible because there's more than one answer here. So we can see that B is 0 across 2 up, and we can see that D is 5 across 5 up. There's another answer, because if I did M over here, it would be -2, 1, and B would be here, which would be 4, 4. Right, so here we have a vectors question, and we're told that vector xy is 3, 2. So we go 3 across, 2 up, and that takes from x to y. And it says write down a vector that is the same size and perpendicular. So first, if we think about the size, what is the size of this vector? I know that this is 3. I know clearly this is 2. So to work out the size of this vector, I could use Pythagoras. 3 squared plus 2 squared is 13. So xy, the vector xy is the square root of 13. It's just, that's the size of it. So the vector I write down has to be the same size. So it's still got to use the numbers 2 and 3. They're squared, so they can be negative, and it would be fine. And it's got to be perpendicular. Now, this vector has a gradient of 2/3. Gradient is the difference in y divided by the difference in x. So here the difference in y is 2, it's 2 up, divided by 3, which is the difference in x. The gradient of this line is 2/3. So the perpendicular gradient is the negative reciprocal. So the other vector has got to have a gradient of -3 over 2. A vector that could be would be minus 2 here, or 3 here, that would work. That would give us a vector that it's got a negative gradient that takes us 3 up when we go minus 2 to the right. Or it could be 2 minus 3. Either of those would be the same size and perpendicular. So the key word here is estimate. So we've got to estimate this value. Now to estimate, we round the values to one significant figure. So 19.4, we're going to round that to 20. So it has one significant figure. 30 is already to one significant figure. Now the square root, I mean, I am going to round it to one significant figure, but it has to be the nearest square number, so you can evaluate it. So just so happens that it's also one significant figure here, so it's 100. Now we'll just work it out. 20 times 20, add 30 times 10, because that's what the square root of 100 is. So 20 times 20 is 400, and 30 times 10 is 300, so the answer is 700. Right, the next question on here, circle the expression that's equivalent to this one. So what we can do when we've got an algebraic fraction, we can use equivalence to cancel it down. So what I'm going to do is I'm going to divide everything by x. So if I divide the denominator by x, I get 1. If I divide 2x squared by x, I get 2x. And if I divide the 1 by x, I get 1 over x. Now dividing by 1 is neither here or there, is it? What we're left with is 2x plus 1 over x. So that is the answer just there.